All right, so the next text we're going to talk about is the alternating series test. Obviously, it only works for alternating series, but someone will try to do it with a non-alternating series. You need to check two conditions. One, that the limit of the sequence is equal to 0, which you should have checked already because that's the step of the nth term test for divergence. The second thing you need to check is that the sequence is decreasing. There are two ways to show this. One, you can show that the first derivative is less than 0, or you can show that an plus 1 is less than or equal to an for all n. Do not say the first and second term it works for. It has to work for all of them. So first of all, is it alternating? Yes. Is the limit equal to 0? Absolutely. Derivative is less than 0? Converges by the alternating series test. Number 2. Same thing, it's alternating. The limit is equal to 0 because the degree of the top is less than the degree of the bottom. And in fact, we all know it's decreasing because the degree of the top is less than the degree of the bottom, so it converges by AST. The third one is supposed to be a trick because it does not converge by AST. If you look at the third one, you see the degrees are equal. So if you tried to do AST, it would have failed the first step of AST. So this one diverges by nth term test. Number 4, does not look like an alternating series, but if you plug in the values for n equals 1, n equals 2, so if n equals 1, you're going to get a cosine of pi, which is negative 1 over n. If you do n equals 2, you're going to get a positive 1 over n. Yes, the n's are changing. I was just trying to say that it's going positive, negative, positive, negative. It is alternating. It's an alternating series in disguise. He's got his little sunglasses on and his mustache. You can't tell who he is. But this is alternating harmonic, and it converges. Now we have to be careful. Just because you see a negative 1 to the n or negative 1 to the n plus 1 does not mean that it's an alternating series. So if this negative 1 to the n plus 1 is combined with that cosine of n pi, it actually doesn't alternate. Sometimes you might have negative 1 to the n and negative 1 to the n plus 1, but you got to see what the result of those two things would do. So you need to write out either a couple terms to see what happens or work through what the powers are saying. Is it an even power? All even powers of a negative number will be positive. If it's odd, it could possibly alternate. Number 6, the alternating series can be used to converge into which of the following? That would converge by AST, converge by AST, diverge by nth term test.